Okay. Real quick, before we start our exam review, because we missed lecture 12, I just want to highlight some very important things that you guys need to know about complement. All right, for complement, in BloodBank, we're really only concerned with the classical pathway, meaning that an antibody has activated the complement cascade. All right, you guys remember from immunology, the complement cascade, C1 is going to be activated, and then it will join with C4. It's going to, it's going to cleave C3 into C3A and C3B. C3b is going to attach to the red cell membrane. All right, that is what we detect in our blood bank testing. If we think about your polyspecific AHG reagent, it has anti-C3b in it. It also has anti-C3d. All right, so C3d is a breakdown product of C3b. Okay, and so if we detect C3b on the red cell membrane, then we know that complement has been involved. All right, C3b or C3d. And then as that complement cascade continues, your complex will be obtained C6, 7, 8, and 9. All right, that is what punctures a hole in your cell membrane. That is what causes hemolysis. Right, your membrane attack complex. Okay. And then there's just one other thing that I wanted you guys to know about. Where is it? Oh, here it is. Complement can be inactivated by heating to 56 degrees. Okay, you guys probably already know that, but that's a really good board of certification exam. They like to ask that. What temperature? So in blood bank, we're very temperature oriented. If you guys haven't noticed already, we have initial spin, we have 37 degrees, we have 4 degrees for those cold reacting antibodies. Know that we're adding another temperature, 56 degrees inactivates complement. Okay. Those are your really two. I wanted you guys to understand what happens in the C3b and C3d, why we can detect that on the cell membrane. Okay. All right, so exam review. We are scheduled to take exam 2. It is scheduled for this Friday. That's the 14th, right? February 14th. All right, and you guys can take it by 11:59 p.m. All right. You'll have 74 questions. It's worth 82 points. So some of those questions are multiple choice. All right. You'll have also some matching and true false. Okay, so before you access the exam, so from here on out in blood bank exams, it's very important that you guys print those charts. All right, so for each exam from here on out, you will have panels on your exams. It's very hard to do panels on the computer screen. So what you're going to see when you print your charts, you'll have blank antigrams. All right, print those out and you can write in your reactions and then you can do your crossing off. All right. Does that make sense to everybody? So you guys don't forget, once you access the exam, you can't exit and then go back and print them. All right, so make sure you print them before. If you go to the library to take your exam, if any of you guys want to, they can print it for you. All right, they'll be able to have them for you. All right. And I want to say too, remember, I don't want to say this exam comprehensive, but remember we're building on things, all right? So we keep adding on. So don't forget your ABO interpretations. Don't forget, you know, how to identify discrepancies, how to interpret those, all right? Don't forget that, all right? So now we're adding on RH and antibody identification. All right, so interpreting your D in week D. Why is reporting of week D so important in donor testing? That's right. If you have a week D patient who is mistyped as RH negative, what's going to happen if that really RH positive unit is transfused into a RH negative recipient? Could cause that patient to build anti-D, right? Could cause a transfusion reaction. So that's why subgroups of A and week D testing is so important in our donor testing, okay? If you have a patient that is negative at initial spin in your D testing, negative at 37, and then positive at AHG, how do you type them? Are they positive or negative? Positive. Right, so even though they're weak D positive, we still classify them as RH positive, okay? If they're a donor, they're labeled as RH positive. If they're a patient that is going to receive a transfusion, they can receive RH positive units, okay? Even though they're weak D positive, all right? What reagents do we use in our weak D testing? AHG. Okay, so remember the process of that test. You're going to add anti-D. You're going to have your test tube. You will also have a control tube. Remember that control tube, it can be a manufactured reagent, such as the monoclonal RH control that you guys use in the 9B lab. That contains everything that is in the anti-D reagent except for the antibody. Okay, so whenever we're doing our testing, that RH control tube must be negative. Okay. When is a really good example of when the RH control has to be included? AB positive, okay? On AB positive patients, think about what their forward typing is. They react with everything. 4+ with anti-A, 4+ with anti-B, 4+ with anti-A, B, 4+ with anti-D. There are no negative reactions in that forward typing, okay? So that's why you must include the RH control for AB patients. We want to make sure those agglutination reactions are due to the patient's antigen expression and not something that may be decoding those red cells causing false agglutination, okay? In our RH lecture, we talked about partial D. Remember the thing about partial D, think about your D antigen. It is very polymorphic, all right? It is highly complex, branched. It is possible for patients to be lacking part of that D molecule. That's where the partial D comes in. So oftentimes those partial D patients, they might test RH positive, but then they might also, remember Landsteiner's rule, for that which you lack, you can build the antibody to. So it's very common for these partial D patients to test RH positive, but then also have an antibody that looks like anti-D as well, right? That's typically how we identify these partial D. There's huge movement right now in BloodBank in the molecular level, identifying all these partial D or variant Ds, okay? What if you're doing your weak D testing and you have a positive RH control? What does that do to your test? Invalidates it. What's a common reason for a positive control at the AHG level? Autoantibody, which causes a positive DAT. All right, so typically if you have a positive RH control, you need to do a DAT on your patient. All right. How would you report out if you had a RH positive control? Can you tell if your patient is Rh negative or positive? Can you report that out? No, all right? Number one, you need to investigate. We're going to do a DAT. Remember, we can also do a treatment. It's the glycine EDTA. It will dissociate whatever's coating patient cells, keeping the cells viable. So then we could repeat our Rh testing, okay? And then that would make the DAT negative. That will make our Rh control negative, okay? Your IAT, remember, it can be a 2-cell or a 3-cell screen. It is running patient plasma with known antigenic profile cells, all right? So they're commercial manufactured screening cells, group O, right? And they're group O because we don't want interference from your patient's ABO antibodies, okay? So they're group O, so we can detect any unexpected allo antibodies or auto antibodies if present. Make sure you guys understand dosage. Remember, dosage occurs if you have a reaction with your patient plasma. If that cell is heterozygous, you'll have a weaker reaction. If it's homozygous, you could have a stronger reaction. Remember, M and N are notorious for causing dosage. JKA and JKB are notorious for causing dosage as well. You could even see it in your RHs. We've had some panels that we've gone over where we've seen dosage being demonstrated in the RH family as well. Okay, so always keep that in mind. In that antibody chart in your lecture note, list all the characteristics of those antibodies. You guys feel comfortable with that? Make sure you understand what reactions each antibody reacts at. You guys don't have to spend too much time on the frequency of those antigens, like 98.8% of the population is positive for little e. You don't have to know that, all right? I just want you to know the characteristics. What phase of reaction do they react at? What are they commonly associated with? Like anti-D is the most antigenic. Kel is the second most antigenic. Lewis A and Lewis B are IgM, cause no harm to the fetus, all right? So no risk for hemolytic disease of the newborn. What else? Duffy A and Duffy B associated with malaria, all right? That built-in defense mechanism against malaria if you're Duffy A negative, B negative. Okay. Remember, rouleau is often interfering with blood bank testing. It can cause false positives. And remember, rouleau looks like a stack of coins. You can see that in the microscope. If you have a unexpected positive reaction in your back type or in your IAT, if you were to look under the microscope, you're not going to see agglutination. You're going to see rouleau. Okay. And if you see that, you can spin that down, spin those tubes down, get a strong cell button, pull off your reagent or plasma that's in there, and then add the exact amounts, usually 2 drops of saline. That is the saline replacement. If the antigen antibody complex has already occurred, agglutination will remain. Okay, if it's only due to rouleau, that saline, all that extra protein has been removed, that saline dissipates the rouleau. Okay. So your cold autoantibodies and your cold reacting allo antibodies, remember, these are not considered clinically significant because they only react at room temperature. Typically, they do not react inside your patient's body. Okay, they're really considered a blood bank nuisance. However, there are some exceptions. Anti-M is a known IgM cold reacting antibody. However, there are documented cases that find anti-M in the IgG classification, meaning that he could potentially react at AHG. Right? If that occurs, then he is considered clinically significant. All right. Remember, cold antibodies, they are capable of binding complement. Right? And this is the reason when we do our IAT testing and our antibody identification, we typically do not use polyspecific because we don't want to pick up on that complement. We're only concerned with antibodies. Okay, so typically in our IAT and in our panel, we are using monospecific IgG reagent. Okay. Some cold antibodies that we talked about, remember anti-I, anti-big I is associated with Mycoplasma pneumoniae. Remember, the big I antigen is found on about 99.9% of all adult cells. So usually if you encounter anti-I, it is going to be an auto antibody, okay? Versus little I, we typically see it after a infection with infectious mononucleosis. Remember, little I is found on cord cells, okay? And we talked about the big I and little I. It's kind of like your ABO and your Lewis, right? It's on the oligosaccharide extending out from that red cell. So that's why we see it on newborn cells. That little I will eventually become a branched oligosaccharide forming the big I antigen, okay? And that usually occurs from anywhere 6 months to 2 years. Little I converts to big I, okay? Like I mentioned, don't spend too much time on those frequencies. Just make sure you guys know about 85% of the population is going to be D positive, right? Meaning that 15% of the population has the capability to build anti-D, all right? Know your special characteristics and reactions. Patient demographics, all right? So make sure you understand the Lewis A, Lewis B negative phenotype, typically seen in African Americans. Duffy A, Duffy B, also typically seen in African Americans. If you guys haven't figured out now, African Americans where sickle cell is prominent, they typically are our problem patients because they're Lewis A, Lewis B negative, they're Duffy A, Duffy B negative, so they will build all of those antibodies because they are exposed to multiple transfusions over their life. Okay, so sickle cell patients cause problems for blood bank. Now, there's mechanisms, procedures in place now that maybe started about 5 to 7 years ago. We try to establish an initial phenotype on these patients and then try to give them phenotypically matched units. Sometimes that's not possible, so they will build, it kind of has reduced the number of antibodies built, but they're still going to build antibodies just because they receive so many transfusions. Right, and know which ones are clinically significant, all right? Your RHs, your KELs, your Duffy, your KID families, those are all AHG reacting. They are considered clinically significant, capable of causing hemolytic disease of the newborn, capable of causing a transfusion reaction, okay? And they're all IgG as well. Right, make sure you guys feel comfortable with the panel. And again, that only comes with practice. So go over all of the ones that we've done in class. I'm going to post some extra ones. Don't forget about your rule of 3. All right, you want to make sure you have 3 negative cells and 3 positive cells. What that means is for whatever antibody you're identifying in your patient, you want to make sure that you have 3 panel cells that are negative, which provided a negative reaction. You want to make sure you have 3 cells that are antigen positive, provide a positive reaction, okay? And that will get you in the 95% confidence level. We have a whole lecture coming up on autoantibodies and how to handle those special techniques that we perform. In the event that you ever have a positive DAT, such as you will see with autoantibodies, or maybe hemolytic disease of the newborn if you do a DAT on that baby. Anytime you have a positive DAT, you have to do an elution, right? A DAT, you guys remember, lets us know that something is coating patient cells in vivo, that's occurring inside their body, all right? We want to know what's coating patient cells, so we can do an elution. An elution is the process of pulling off whatever is coating patient cells, not complement, all right? We're not worried about complement in this situation. It has to be some type of antibody, okay? Pulling off that antibody from the cells. It can be a heat treatment, an acid treatment, or the Louis freeze that we will talk about later, and then we can test that eluate. That's the elution. The elution usually involves lysing those cells. So in an elution procedure, those cells are no longer viable. You cannot use them, all right? We're just using the supernatant, the eluate. All right. Remember, there are some techniques in blood bank that we can use to further identify an antibody, such as enzyme. You might see enzyme referred to as Fison or papain. Okay, and remember what enzyme does, Think about the sialic acid on the cell. Enzyme is going to remove that sialic acid. So your M, your N, and your Duffy, they are all going to be removed, all right, in S. M, N, S, and your Duffy A and Duffy B, okay? So then you're left with your RHs, your KIDs, and your KELs. So if you're dealing with a Duffy antibody and you're trying to make sure there are no underlying antibodies, you could do an enzyme treatment. That would give you some negative reactions and allow for further rule out, right? And then neutralization, if you're dealing with a Lewis, A or B antigen, neutralization, again, commercially manufactured soluble antigen that will absorb out that Lewis, and they'll give you some negative reactions. We've seen some examples like that in the panels that we've gone over. So remember, sometimes in our IAT and in our panel, we will use LIST. It's a low ionic strength solution. What it does is it removes the water from your test tube, further allowing antibody uptake onto the cells. So it further enables visualization of agglutination, okay? And then remember, AHG, we use it. Think about an IgG antibody, very small, all right? It has a very hard time bringing the cells together, so we can visualize that agglutination. AHG binds to the antibody that's coating the cells, and then binds to another antibody coating the cell, brings it together, forms that lattice formation that we need to have. We need to have that in order to see agglutination, okay? So that's the purpose of the AHG. Your RH nomenclature, make sure you guys are familiar with your Fisher race and your Weiner, okay? As you guys are presented with questions on the exam, it's very important that you think about the theory behind each procedure. Think about the test and why we do it. That will help you answer questions, okay? There's some language that we talked about, public antigen versus private antigen. Remember, a public antigen means that most of the population is going to be positive for it, right? Most of the population has it, versus a private antigen, most people are going to be negative. Only a very small amount of the population is going to have that antigen. Okay. What's the most common example where a private antibody can be detected? What's the situation we're going to see there? So if it's an antibody to a private antigen, that means most of the population is going to be antigen negative. Okay, think about our screening cell that we do on every patient in BloodBank. Okay, if our screening cells lack that antigen, we cannot pick up the corresponding antibody to it. So what's going to happen if your patient has an antibody to a private antigen is that your IAT is going to be negative. But in the event you do a cross match and that donor unit is antigen positive, you will have an incompatible cross match. That is the #1 way that BloodBank picks up on an antibody to a private antigen. Okay, does that make sense to everybody? If you did have a public antibody, meaning that 98% of the population is positive, but you have a patient that's in that 2% of the population that is antigen negative and has built the antibody, what do you do in those situations? Is it going to be easy to find compatible blood? No. All right. Typically, you're going to have to seek your donor registry. They're going to have a list of patients that are antigen negative. They might even have to call them in. All right. And maybe they even have a frozen stock. You can freeze red cells up to 10 years. And so if they have a donor that has donated and they have a frozen unit, they might have to pull it out, thaw it, deglycerize it, and then it'll be ready for transfusion within 24 hours. Okay. The I antigen we talked about, again, 99.9% of the population, adults, are going to have the I antigen. Most adults will have the H substance. The only phenotype that won't is if you are Bombay, all right? And again, those reaction temperatures, which ones are destroyed or enhanced by enzyme. Which ones are enhanced by enzyme? RH and KID, all right? Sometimes even Lewis, sometimes, but that's variable. And then which ones can be neutralized? Lewis, and if you have a P1, it can also be neutralized. Kel, KID, and Duffy, those are the most common ones that you will see in blood banks. Spend some time on them, okay? And remember, we talked about complement. Once that complex is attached to the cell, C5, 6, 7, 8, and 9, that's what punctures the hole in the cell, causing hemolysis. DAT, again, we're detecting what's coding patient cells in vivo. And then which complement component is detected. Think about what's in your reagent. So your monospecific AHG reagent includes anti-C3b, C3d. All right, remember in the complement cascade, C3b is what attaches to your red cell membrane. That is what we can detect. All right, and then as C3b, C3d is a breakdown product of that C3b. Okay, so we can detect C3b, C3d. That's what's in our reagent. That's how we can detect complement in blood bank. Okay. Remember, if a patient has a positive IAT, you do the antibody identification and you identify an antibody, you must give them antigen negative blood. Okay, so if they have anti-Cal, they have Duffy A or Duffy B, JKA, JKB, the donor unit that you choose must be antigen negative for that antibody. Okay, what's going to happen if you give them antigen positive red cells for the antibody they have? You've caused a transfusion reaction. Right, so that's why it's very important in blood bank that we honor all antibodies that are currently identified and those antibodies that have been identified in the past. Okay. And make sure you can interpret a RH phenotype from information regarding antigens present on the cell. This is what we did in those pre-transfusion case studies. Okay, if I'm giving you D negative, big C positive, little e positive, big E negative, little e positive, what are your possible genotypes, Fisher, race, and Weiner language, okay? Interpreting a pedigree chart like we did in those case studies as well. And remember your lectin to detect the A1. So if you have a discrepancy, we need to run A1 lectin and A2 cells. The lectin for A1 is from a plant extract. It's Dichloris biflorus, I think. That's what it is. Remember, Coombs is the one that actually discovered, he's a scientist, he discovered the AHG reagent. A lot of older texts will call your AHG reagent Coombs reagent, okay? You will hear that language. You will also hear check cells referred to as Coombs cells, okay? Cold autoantibody, remember, cold autoantibody will react at initial spin. So it could cause some reactions in your IAT. It can also affect your bat type of your ABO testing, okay, because it is reacting at initial spin. Lutherin A and Lutherin B. Lutherin B is a public antigen, meaning that the majority of the population is going to be Lutherin B positive, versus Lutherin A is a private antigen, meaning that the majority of the population are going to be Lutherin A negative. Just a little bit of a language. Once a patient has built an antibody, we call them immunized to that specific antibody or antigen. And this all goes back to, we talked about humoral immunity, the building of those antibodies. So once a patient is exposed, those B cells are going to be activated, turn into plasma cells. They're going to build those antibodies to that specific antigen epitope, okay? All right, so here's some sample questions. When should a D mosaic, or another word for that's partial D, variant D, be suspected? Weak D positive, and what else? They're going to have a positive IAT, and antibody identification is going to look like an anti-D. So it's going to look like an auto anti-D. Okay. However, the key there would be that your auto control is going to be negative. Okay, because remember, they built the antibody to what they lack. All right, so they're not, if you test patient plasma with patient cells, their antibody is not going to react with their own cells because their own cells lack that part of the D molecule. All right. When would we see dosage? When your panel cells are heterozygous versus homozygous. And remember, homozygous will give us a stronger reaction. What must be done if you have a positive IAT? Must do a panel for antibody identification. Remember, that IAT is only a screen. It's only kind of a preliminary letting us know that there is an antibody there. We can kind of get an idea, but with only 2 or 3 cells, that does not get us into that 95% confidence level, okay? So we must run more cells to prove which antibody is reacting, okay? What's the purpose of an elution? Remember, if something is coding patient red cells, we can do an elution, pull off that antibody, all right? That elution pulls it off, and then we are left with the antibody unbound in the supernamed. We can repeat our IAT and our panel and identify what antibody was coding patient cells. Okay. What's the purpose of neutralization? So you could, if you have an antibody that is causing reactions, like one of the examples, we had kind of reactions all over the place, initial span 37 and AHG, very hard to rule out. You could perform neutralization if you suspect like a Lewis A or a Lewis B, that will make those reactions go away. So then you can identify any underlying antibodies, okay?
It's not only Lewis.
It's not only Lewis. Lewis is the most common, but you could also do P1, I think, but you have to have that soluble antigen, which is commercially manufactured, so you have to purchase it. A lot of blood bank hospitals are not going to purchase that soluble antigen. Lewis is the most common one they're going to keep on hand. And then what are check cells coded with? IgG. So check cells are group O positive cells that are coded with anti-D. Anti-D is an IgG antibody. So think of check cells as IgG coded cells, okay? And remember, the purpose of check cells is to confirm a negative AHG result. So if you have IgG coded cells and you add it to anti-IgG, what's going to happen? Agglutination. So check cells confirms our negative AHG. It is not a reflection of your patient test. So it should not be interpreted as a positive reaction with your patients, okay? It is kind of a built-in internal quality control that blood bank does. Number one, to make sure that AHG was added, and number two, to make sure that cells were appropriately washed. We want to remove all of the unbound protein, okay? If you have excess protein, that can neutralize your AHG, causing a false, somebody say it. If your AHG cannot react, it causes a false negative, all right? So if you have a patient that is B and they tested positive after the addition of AHG in the weak D test, how do you interpret that test? How do you interpret your patient's RH type? Yes, so they are B positive, okay? And then you would transfuse them with what? B positive. Could a B weak D positive develop anti-D if the person is what we call partial D, mosaic D, variant D? Yes, they could. And the reason for that is because that D antigen is so polymorphic, very complex. And these partial Ds lack a portion of that molecule. So they could build an antibody to a portion of that molecule. All right, so they could. If you were using high protein reagent in your D test, and both your weak D and your control tube are positive, what would you do? Number one, can you report out your RH if your weak D control is positive? What do you know about high protein? High protein can cause rouleau, can cause false positives. So in this situation, you would want to try your test with a different reagent. Maybe you could use a monoclonal anti-D reagent, all right? Sometimes you might even use a monoclonal polyclonal blend, all right? You just want to reduce the amount of protein. What's the cause of a positive weak D control? Positive DAT. If high protein anti-D is used, we just talked about that, how should it be resolved? You would want to use a monoclonal reagent. What if the above problem is not resolved? They could. You would want to do a DAT. And then in all situations, if you're in a trauma situation and they're wanting blood right now and you're working on that, you could give them RH negative, okay? What about Lewis B? Can he cause hemolytic disease of the newborn? Is he considered clinically significant? No. Can we neutralize Lewis B? Yes. And then is Lewis B IgG or IgM? He's IgM. What blood type are our screening cells? Group O. And then what reagent detects complement in vivo? AHG polyspecific. And then if your polyspecific is positive, you would want to repeat with monospecific anti-C3b, C3b. Okay. How can a typing discrepancy due to a cold antibody be resolved? You could warm it. And then which antibody is associated with malaria? That's your Duffy. And then which antibody is the most antigenic? Is the second most antigenic? Kel. Which antigen diminishes during pregnancy? That's your Lewis. And then what are some techniques used to resolve multiple discrepancies? You can run select cells. You can also perform your neutralization. You can perform enzyme treatment. You can look at your phase of reactivity. You can look at variation of reactions, look at your pattern of reactivity. Those are all things you have to take into consideration when you're dealing with multiple antibodies. If a patient has a previous antibody and is now testing negative for the antibody, all right, so their titer has dropped to undetectable levels, what type of blood should be given? You still have to give them antigen negative. That's why I said we always have to honor antibodies, even if they're not currently reacting. We must always look at patient history. Okay, so if you 10 years ago, you identified your patient with anti-E, but now he has a negative IAT, you still must give him E negative units, all right? What would happen if you gave him E positive units, even though his antibody is at a low titer? Transfusion reaction. Upon exposure, that anti-E, that IgG titer is going to spike, going to attack those donor cells. Your patient's going to go into a transfusion reaction. When should you consider polyagglutination? Think about what an AB positive patient looks like on the front type. All right, that's why we run the RH control. So always consider polyagglutination if all your front typing results are positive. Okay. What might cause variation in the reaction strength in the antibody screen? Dosage. What else? Multiple antibodies, all right? And then which blood group can build anti-H? Bombay. Could your group O build anti-H? No, because they have the most H substance being exposed, right? Because they don't have either the A or the B antigen. So your blood types that will typically build anti-H are usually A1 and A1B, okay? Polyspecific AHG, we already talked about, it will detect your C3b, C3d. And then how can a rare antibody that is not on the screen or panel be detected? And remember, that would be like a private antigen. So your screening cells are going to be negative, but that donor unit is positive. So your patient's antibody will react with your donor unit, causing an incompatible cross-match. Who must have a weak D performed if the D is negative? What group of patients is that so important in? Donors. And depending on, I will tell you this, a lot of facilities have taken away the weak D testing except for babies and moms. Sometimes they only do it on moms and babies. But definitely your blood donor. Right, what if an allo reacts at room temperature, but not at 37, but again at AHG? We saw this in one of our examples. What type of AHG is being used? Polyspecific. So what would you want to do? You want to use monospecific AHG. And then your Fisher race and Weiner nomenclature. What's the most probable racial background of someone who has Lewis A antibodies, Lewis B, and Duffy A? African American. And then anti-I will react with what type of cells? All adult cells, right? Thing is there, it will not react with cord cells because cord cells have little I. Which antibody can cause hemolysis in the IAT at room temperature? We saw a case study like this as well. IgM, but what type? Lewis. And then what is an example of a phenotype? Well, you have your blood types, A, B, O, and then so D positive, right? That's your phenotype. We don't know what the genotype is. Is it that D antigen being expressed on both genes? Only one gene, okay? And then here is a panel. And if you do your crossing out and look at your pattern of reactivity, it matches E perfectly. All right, any questions? All right, so this week, as you guys are studying, if you have any questions, please let me know. I will be available. I'll be in my office and through email.